Hello, ladies and gentlemen. Mr. Donahue again, here with some chemistry problems. Chapter 6.4, Wave Behavior of Matter. In class, I told you guys how frustrating and crazy this stuff seems because, everyday experiences, you don't experience the wave properties of matter because things are really massive. You generally don't see the wave of a person, right? It'd be weird if you did. Think something was wrong with them. All right, so we're looking at 16. It says, according to the Heisenberg uncertainty principle, it is impossible to know precisely both the position and the blank of an electron. So this is just kind of a definition question, and it's momentum, right? So that's it. You read it and went, all right, that's what it is, or you didn't, and you were lost. 17 says the de Broglie wavelength of a blank will have the shortest wavelength when traveling at 30 centimeters per second. So we got to look at this wave equation for matter. So the wavelength equals Planck's constant over mass times velocity, right? So V is velocity. It's not frequency, it's velocity. How fast is something going? So they already told us what the speed was, so that's going to be a constant thing. We don't got to worry about that changing. So H is a constant. So the only thing that we're really examining is, well, what happens to the mass? As we increase the mass, right, what happens to the wavelength? The wavelength, we're increasing the denominator, the whole thing's going to get smaller. So if mass goes up, the wavelength goes down, which makes sense, which is why things that you see every day, like your neighbor, don't look like they have a wave property to them because they have kind of a high mass, so their wavelength is really small enough that you wouldn't notice it. But especially when we're looking at really small things, like an electron or something where the mass is really low, so if we were to look at what happens as the mass goes down, the wavelength of it goes up. Electron microscopes actually make use of this. They get the velocity really high for the electron. The mass is really low, so its wavelength gets bigger. It's a noticeable wavelength that you can use to measure things with electrons. Right? They shoot electrons at stuff, and they use the wavelength of the electron instead of light because the wavelength is smaller, and you can see it. So if it's asking for the shortest wavelength, we're talking about the most massive. There, I got to the point. You happy? So the most massive thing on this, definitely the planet, right? Unless you have an interesting marble collection that I would like to see. All right, 18. It says, what is the de Broglie wavelength of a 2 kilogram object moving at a speed of 50 meters per second? So again, we're going to use that formula that we introduced, Planck's constant over mass times velocity. So we plug in, well, H is a constant. That's 6.63 times 10 to the negative 34 times, all right, bottom of the mass in kilograms. It's important that it is in kilograms, so 2.0 kilograms. Times the velocity has got to be in meters per second, which is what they gave us, so times 50. So we plug and chug, and we get a wavelength of beep, bop, boop. Hey, cool. That's 18. All right, 19. Last one for this set. The de Broglie wavelength of an electron with a velocity of 6 times 10 to the 6 meters per second is blank meters. The mass of an electron is given right there. So again, we're going to use this formula. Lambda equals H over M times V. All right, well, H is 6.63 times 10 to the negative 34 all over the mass of an electron, but they gave it to us in grams. All right, so we're going to have 9.11 times 10 to the negative 31 kilograms, right? It's going to be even smaller than that if we're talking about kilograms. So I just converted grams to kilograms there. Times by the velocity in meters per second. So 6 times 10 to the 6 meters per second. I ran out of room. So now it's just plug and chug using a calculator correctly, and you should get answer E. They put answer D because it is almost the same thing, and if you forgot to convert grams to kilograms, that's what you would have got, but you would have been wrong. All right. So yeah, hope you found that helpful. rewind, replay, do whatever you need to. Ask questions in class when I see you. Until next time.